Alright, so this is my computer, my virtual computer that I made. Uh, there's a couple of things wrong with it, but I did manage to make it work the way I needed it to for this particular mission. So, if we go through, hopefully we cut that out. We are looking at a deliciousness score, and we're supposed to sort it from least to greatest, and that is represented here with this fake little encyclopedia or whatever. So what ends up happening is I need to input and take in all of the data one by one, and starting from here it'll make its way all the way down the list. And then what I need to do is I need to sort the data using my computer and its functions and features. I can do that by using a very basic assembly editor, which I have programmed myself, essentially. Not like I programmed the whole thing, but I mean like I have instructions like branch off if greater than or less than or equal to, or go to this function and then come back, or add these two numbers and put the value in this particular register of data, or this part in RAM, or, well, I don't get to go directly to RAM, but I can put it in the register and then take it from the register and put it in RAM, blah, 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 blah. So anyway, I use the instruction set that I've set up for myself with my system, which isn't entirely my design. I was told the system needs to do this, that, and the other thing, and I built the machine to do that, and the other that. So, as it goes, I had to write a program to make this work effectively, because while I could just be really cheesy and, look at this list and go, okay, do this and that, and then this and that, but I can't just tell it that, because what happens is there's actually 32 of these tests, and I could, in theory, cheese it out and do it like that. That's not the purpose of the exercise. It's not how we do things here. We do things the right way, because that's the right way to do things. So I wrote down some notes for myself, like how I'm going to do things, but I needed a way to sort. I had a sorting algorithm in mind, and I kind of took from that idea with an actual algorithm, and I found out that mine's basically the same idea, just worded a little differently and done things in a different order. So I just did what theirs does. And then I needed a swap algorithm to swap two variables. So this 3 lines of code will swap 2 variables in place without using a third temporary spot, which is pretty nifty. But as it goes, what happens is we run through the code and it should spit out the sorted values. So if I go ahead and hit the play button here, and this is going to go kind of a fast speed, it's going to, well, if I hit just this button, you can see it goes step by step, line by line. But if I hit this button, it'll go by pretty quick. Faster than you can probably really read. You can see the blue line where it's actually at in the code, which is actually represented as numbers here, because all of my instructions are just numbers, because that's how computers work. So it runs through the code, and then it does the stuff with the RAM. Basically what I'm doing here is I load all of the data into the RAM. So this was originally the whole original list, and now what I'm doing is I'm working through the list by going, I want to see this value and I want to see that value in a couple of registers. If this value is greater than that value, then we need to swap them. And then when it's done swapping, if it's swapped, it'll run back to the beginning and start over again. If it does not swap, it will go through and continue through and keep counting up through the RAM until it gets to another value that is greater than the one on the right. And then it will swap, and then it will go back to the beginning, and it'll start over again. That little ding noise was completing the first test. So it takes a little while to do it like this. An actual computer is a lot faster, and this is just a fast forward mode. It's not like actual processing speed. This is just a way to help visualize better what's going on. It also allows us to pause in the middle of something and say, okay, this number is getting pretty close to over here, and I know right about here is when I'm having an error. I can pause, and I can go step by step by step until I get to the problem. And then I can rerun if I'm not quite there yet, or if I decided to just let it run until it does error. What happens is it keeps going through this, and it'll keep pushing greater values to the right over and over again until it gets to the end. It knows that it's in the end because we know that there's always 15 in this particular set of data. There's only 15 datas per test. So I know that if I go to get to the next step, and that next step is 15, then we're done. That's it. We made it all the way, then we must be done, because we've always been checking all along the way that it had to be greater than or not. And there's the second test done. Now, what we actually do when we actually want to test the thing and we think everything's kosher, we hit this 10 kilohertz button and it goes zap, and it just blasts through all the tests, which is a really good feeling, because it's like, it worked through all 32 of them. We can say with pretty stable confidence that the algorithm that I have in place here is doing the job correctly according to what they wanted me to do for the test. And that is one of a few of these programming tests. One of them was I had to play a card game with a robot. There's a robot racing. There's a few of these. I haven't even looked at these. I've been going one step at a time. So I'm not even going to get into any of that. But the point is, the sorting is working, and I'm pretty dang happy with it, because it took me a little longer than I was really expecting, because I already know how to sort things, but putting it into computer terms is very similar to the thing that we do in elementary school, where they have you write down the instructions for making a peanut butter and jelly sandwich. I don't know how many people listening to this particular TED Talk, or whatever you want to call this, is the peanut butter jelly sandwiches. You have to write down the instructions, like verbatim, exactly, verbosely, because they wanted it as an exercise of breaking down the steps as far as you can, and you really have to do that in computer programming way more than people even give it credit for. A lot of people think it's just, oh yeah, I'll just tell the computer do this and that. No, it's you're giving it a bunch of numbers in a sequence, and those numbers in a sequence get computed with ifs and ors and graders and ands, and yeah, and it spits out stupid crap like this, and it just helps me respect computers just that much more. I'm starting to ramble at this point, so I'm going to wrap up the video. But yeah, that is my virtual computer sorting virtual deliciousness.